Where are we now, Uncle Tabsy?
In the kitchen.
What are we about to do?
A science an experiment. What experiment?
A scientific experiment.
Scientific experiment.
Call it the iron oxide experiment. This is one of the things that you can expect to see on the online. There he is. MJ, you're still joining us here. So this is quite a wonderful thing that we're about to explore. Exactly what is this experiment demonstrating from a scientific point of view?
So what this is a bit of a preview for our Saturday masterclass, which is all about rates of reaction. Basically, how fast or how slow a chemical reaction can occur. And what you have there is steel wool. And what we're going to do is we're going to do a chemical reaction where we oxidize steel wool. In this case, it's by burning the steel wool. And we're able to burn it because we are utilizing basically increasing its surface area. So just like when we chew food, we increase the surface area so that it can digest quicker and more easily within our body. It's the same principle that is happening here with the steel wool.
Oh, you're taking me back to grading. Great. I love this so much. I love this so much.
Okay, obviously, as you would do with any sort of science experiment that involves some potential fire or smoke, because you want to make sure that safety first. And that's why I've brought my fire extinguisher from my car.
From your car?
Okay, that's not from my car.
That's the first time you've ever picked up that fire extinguisher.
This is actually the first time. I didn't know how heavy it was. I didn't expect that. But we've got that there, and I've got my gloves on because we are working with steel wool here, and so we don't want any cuts or any pricks going on there. It's all about safety.
Absolutely, absolutely. So, MJ, as you've explained, we've got some steel wool that you've unraveled into a bowl. We're using a glass bowl, and together with that, we have a 9-volt battery. So what are we expecting to see, and how does the experiment work?
Well, what you do is you take the steel wool, you unravel it, and for lack of a better word, you fluff it out. And what science basically tells us is that for a chemical reaction to occur, it basically needs a bit of energy to get started. If there's any physical science listening, they will recognize the word activation energy.
Yes.
If you don't know that word, don't worry, it's still fine.
Catalyst, perhaps, the catalyst.
And what we're going to do is we're going to be putting in energy using a battery. So this is our form of energy. And the minute we put this energy into the steel wool, we are basically activating the chemical reaction. Now, any brand would work. And the minute we touch it to the steel wool, basically what is happening is chemical potential energy is going to change to electrical energy. And then we'll see what happens after that. There'll be another conversion.
And before you do that, Tabsy, of course, you've got to just, for a safety point of view, check that the battery's working, so you've got to put it on your tongue. I'm kidding, Tabsy. Just kidding.
I mean, I don't know much about science, but I'm sure that that's not how it works.
5 seconds.
You really are trying to get my blood. Okay, cool. So I'm going to do that now. Do I just throw it into the bowl, or do I touch it and then remove? Just confirm it.
Touch the top and take it away.
All right, let's go.
Now we look at it, see? So the 9-volt battery now activates the electric energy.
And you can pull it away.
Touch it at a few spots, and you can see it already starts. So right now, what exactly is happening? The electrical energy is going into the steel wool. And of course, is it because the steel wool has a low resistance?
Yes. Basically, for a lack of a better word, we are short-circuiting the wire. It's basically getting such a high resistance that it's overheating, and that heat basically begins to glow a bright red color. And basically, the heat allows the metal to react with the oxygen in the air. So we get in a whole chemical reaction kick-started right there.
So you get the iron reacting with the oxygen mixing together, and then you get like iron oxide vibes
going on all over the bowl.
And it's an exothermic reaction, if I remember correctly, right?
That is correct. It is an exothermic reaction, which means that it gives off heat.
Yes, exactly. There we go.
Well,
Taxi.
that's it. That's
done well.
how it works.
You've done well,
This is so fascinating.
Right?
But it's also got me thinking
What?
how many times you've had to dispose of your steel wool in your kitchen.
Yeah.
And at the same time, maybe your remote control for your TV has sort
A
of
9
run
volt
out,
battery?
of batteries.
What
maybe
kind
not
of
maybe
remote
not
are you operating in your house, Babsy?
Maybe not the battery for your remote control, but just like a battery like this.
Yeah,
It's like
yeah.
you want to throw it away. What you don't want to do then is maybe chuck it in the same bin
That
as
could
your
result-
steel wool,
that could result
because
in
that can
very dangerous fire.
cause a fire.
Yeah.
And if you don't have one of these fire extinguishers, you're in trouble, my friend.
Wow. MJ, this
Yeah.
is absolutely amazing. If I find some time, I might just sign up to your science classes and just kind of observe and learn and, relearn again. This is wonderful. Thank you very much for this demonstration.
Wonderful.
Look at
Anytime.
that, guys.
Thank you so much.
This is.
We are creating iron oxide right here,
Right here.
before your very eyes.
In a kitchen
It's amazing.
bowl.
It's science.